Anyway, let us start the class. The others who will join late will, obviously have the access for the recording there. Now, in the third unit, we have the second part as the enterprise architecture styles, or what we call it as the Java enterprise styles, Java enterprise edition. Now, today we're going to look at what are the architectures, different enterprise architectures. Now, if you look at the uh, okay, now if we look at the different architectures, what we have, our enterprise architecture styles, is that we have the first thing as what we call one-tier architecture. Then we have two-tier architecture, three-tier architecture, and the n-tier architecture. So these we have as the four architecture enterprise architecture styles. Now sometimes a question comes that explain about the enterprise architecture or entire enterprise architecture. So if they ask you about enterprise architecture, explain about Java's enterprise architecture, then you have to explain all the four, depending upon the marks that is allocated to the question. Suppose if it is for 7 marks or 10 marks, obviously you have to explain for all four architectures. But sometimes what happens is this specifically mentions that explain about the entire enterprise architecture. So then, depending upon the marks, you just answer entire architecture. Now, anyway, let us talk about what is the first tag. Not the first tag actually. Let us talk about what is the one tier architecture or a single tier architecture. Now, in the single tier or a one tier architecture, what we call is that it consists of the business logic, the presentation logic, or the business rules, and the data access layers on a single computing machine or on a single architecture. So it's just like a standalone system where you have the user interface, which is the presentation logic, and then the rules in the sense the computation or a coding part or the business logic there. And then if the data is stored in the database, or the data can also be stored on files. So we call it as data access layer. And all these three things are present on a standalone single system. Now, this type of architecture is relatively very easy to manage, and there is no problem as such with respect to the data consistency. That is, there is no inconsistency in data because data is stored at a single location. But the major disadvantage is that uh, with this architecture is that the applications cannot be used by multiple users, because the database, the application, the entire application with the presentation logic, business logic, and the data is present on a single system. So the biggest disadvantage of this system, this type of architecture, is that the multiple users cannot access, or the application cannot be accessed by multiple users, because there is no means of sharing data across applications. So that is the major disadvantage, but this is one-tier architecture is a very simple and easy to manage and implement. Now, next thing what we have is the two-tier architecture. Now, in this two-tier architecture, if you look at where is the, okay, if you look at the first tier is nothing but it is the actually a client, and the second tier is nothing but the server. So there is a network involved in this. That is, a client sends a request and a response from the server is returned back. This is known as the two-tier architecture. In the two-tier architecture, the first tier is the client and the second tier is the server. So in two-tier architecture, the business logic and the data access is separate. And basically, the second tier, which is the server we call, is not an application server or a web server. it is a database server. The application, the business logic and data, they are both separated between these two tiers. And the architecture, this type of architecture, the application exists on the local machines, which are known as client machines. And the data is stored on a server known as a database server, which is the second tier. In the two-tier architecture, the processing is performed on the client. It's on the client machine itself, where the application is running. So application runs on the client machine itself, and server simply controls the traffic between the application and the data. So data is actually stored in the second tier, and entire application is on the first tier. The main advantage of this tier architecture is data is like on a central server. So multiple users can access a common database. And this two-tier architecture is also referred as a client-server architecture, where client communicates with the server. The user interface or the logic, that is GUI, and the business logic, whatever is implemented, is on the client side, and server only has the database or the data access. This is the second tier architecture, which is a traditional architecture. Now, coming to the next thing, three-tier architecture. Now, in the three-tier architecture, actually, the client doesn't have that much load. In two-tier architecture, client contains the application itself. The processing, everything happens on client itself. But here in the three-tier architecture, the client only has the presentation layer or the GUI. And the application actually is running, or the processing is actually happening on the application server, which becomes the second tier or the middle tier, we call it as. And then the third tier is the data layer or data access layer, which is the database server. So in the three-tier architecture, the first tier represents the presentation layer, which consists of graphical user interface to interact with the user. There is no processing as such done in the first tier. Then the second tier or the middle tier represents the business logic, which consists of the main implementation. And this implementation or main logic, it is actually doesn't happen by itself, doesn't run by itself. The user actually communicates through the presentation layer with the second tab. So there is no access direct. The client directly cannot access the data. It has to go through the application server, where the entire business logic or implementation, entire business logic is implemented there. Then the third tab represents the data layer or data access layer, which consists of actually the logic behind the data access, or logic behind how the data is stored. The main advantage of this three-tier architecture is that it provides flexibility in designing an application compared to this two-tier architecture, because multiple interfaces can be built. That is, the clients can use multiple interfaces and deployed without changing any of the business logic. What happens here, what calculation you do, what computation you do, without changing the business logic, neither changing anything with the database. So the main advantage is that multiple interfaces can be built and deployed without changing the business logic or the application logic. So this is where is the where we the benefit or the advantage of using three-tier architecture. Now remember, in two-tier architecture works traditionally is known as a client-server model, where client is going to have the application, runs the application. Server only handles, in two-tier, server only handles the data layer or the database. In three-tier architecture, client doesn't do the processing of the business part or business layer or any complete implementation. So application is not running on the client. Client is only views, like using a web browser or a wireless device. Client can also be on a wireless device, can view or GUI is there for the client. The entire processing is done, or the implementation is done on the for the application on the application server. So that is why, I mean, we can change the GUI without affecting the application or the logic behind the application. Now, next, when we come to this, the fourth type of architecture is the entire architecture. Now, in this entire architecture, if you see the diagram I have used for the three-tier architecture and entire architecture is the same, but the only difference is that the entire architecture here, there's only, I mean, for the presentation part, we have a client. There can be many clients connected to the application server. Even in the case of a three-tier architecture, there can be any number of clients connecting to the application server. So there can be multiple clients connecting. And even in the entire architecture, there can be multiple clients connecting to the application server. But here we call it as entire because it's a combination of two-tier architecture and a three-tier architecture. So in two-tier also we have a client, but client doesn't do anything. I mean, client performs the entire application. Server doesn't do anything. Server only handles the database access. But here in entire, what happens is this application part. There can be any number of clients, but the application, there are several layers over here with the application server. And obviously, we're going to have database server also for data layer there. Now, here, along with the business logic, we can have many infrastructural services between the client and application server and the database server. So there can be any number of infrastructure services or any tiers between the client and the application server as well as the database server. So actually entire architecture has numerous layers. Now here we had only in three-tier architecture we said that this is the presentation layer, this is the business layer, and this is the data access layer. But in entire architecture, there are numerous layers. That is why we are calling as not 4-tier, 5-tier, but entire architecture. And the entire architecture consists of the user interface, which is going to be a web browser. That is the client side. It's going to be a web browser, or it can be a desktop application, or even we can use a wireless device. That is the user interface part. Then the presentation logic defines what is going to be displayed to the user and how user queries are handled. Then comes the application logic or the business logic, where we have the rules through which we interact with the application's data. So between the business logic and the database server, we can have many infrastructure services. For example, these services are used to provide additional functionality, such as transactional support, such as messaging, what all is there required by by the application. For example, sending a message, sending an SMS, sending an email before the database is accessed or data is saved, or if some record is updated through an application, we can have a service to send an email or send an OTP or send an SMS there. As well as transactional support services within the infrastructure services means, suppose there is after buying everything in the shopping cart, when a payment is made, when you're trying to make a payment, you have to contact a bank or some third party for the payment to get handled. So when we access the third party, obviously third party is not part of our application. It's somebody else. So the payment system has to be. The payment has to go through, and then if everything is proper, we need to get a response back from from the bank or the third party. So those are the things. Then only orders can be placed, or the order is finalized and saved in the database. So that is what the entire architecture. There is a layer which provides infrastructure services. that is such as messaging or transaction support required by the application. This actually is used to provide some additional functionality. Then obviously the last layer is nothing but the database layer or data access layer. Now, furthermore, the main advantages of entire architecture is the maintainability. The first one is the maintainability. That is this type of architecture allows us to create applications that are easy to maintain. Then the next important thing is the consistency. It allows the development of what you call enterprise applications. As well as for the enterprise application, the data has to be consistent. So obviously, when we are using a database there, and so when centrally it is put, and number of clients can access that data. So what actually happens is any client manipulates something, it's only one data that is database, that only one layer which is getting manipulated. So consistency is provided. Then the third thing, the third advantage is that interoperability. That is, it allows the implementation of different components in different layers to support different technologies. So remember, interoperability is not just implementing different components of different technologies. So when we say different technologies means just not only the Java, what you're going to use enterprise application. You can have Java with that. You can have some other platform you can use. So that is most important in interoperability, that it supports different technologies. Then the fourth thing is the flexibility. Obviously, here it's we can design various components at different layers very flexibly without changing the business logic. And then the final part is the scalability. That is, the new components can be added without affecting the performance of the existing system. So you can add new components to enhance the business logic, and very easy. Without without actually affecting the actual performance of the system. So these were the four types of architectures, what we call them as the enterprise architectures or enterprise architecture styles. Now let us look at or talk about the next thing, which is what do we call features of J2EE enterprise platform. Now here, there are several features of using Java's enterprise platform. The first is the platform independence. That is the first and the foremost feature. Now, as you all know, Java itself is a platform independent language. That is, can be created by once and can run anywhere. So this is the actually most important feature of Java. So obviously, when we are creating enterprises from Java, through Java, using Java, in today, a wide range of information is available in different formats, which is spread across multiple platforms. So obviously, since we are talking about Java's enterprise styles, since Java is a platform independent, so even this architecture will be a platform independent. Then the next thing is what we have is the managed objects. Now, Java's enterprise style provides a managed environment for its components. That is the application in Java can be, the behavior of the applications of Java can be easily changed without actually changing much of the implementation part or much of the implementation code. Now, this is actually a property of J2EE application, it is easy by which we can modify and control the behaviors of the application without actually changing their code. Now, these properties actually are more cumbersome, and this type manage objects is more what do you call there is some type of complexity involved. But once they are created, it will be very easy for large scale applications. Or once the managed objects are used, it will be very flexible for large scale applications where different components will interact with each other. So that is one of the features that we can use managed objects. Then reusability is there. So obviously, when we are talking about components and all, reusability is one of the another important aspect of programming uh, complex applications. Is The meaning is that we need to develop applications that require, obviously, frequent changes or updates. So to achieve this, we can have individual components or create individual components for the application, and then these components can share their functionality with the others. So this is what is the major thing with respect to the object-oriented programming. That is, we can create objects once or components once. Components are nothing but objects. So components once, and then we can use those components or call those components anyhow or anywhere we want. So that is the reusability feature. And then we have is the modularity. And obviously, when we are going to have multiple layers in the architecture, each layer will have its separate task to accomplish or business logic to accomplish. And since we are talking about large scale applications or complex applications, modularity is one of the feature which is going to help to maintain the code with much ease. And it's actually we are trying to break up a large application into a different application into a small pieces or small modules, and each with its associated or respective task assigned or a business logic assigned, that is individual task or individual logic assigned. So when individual logic is assigned, what actually happens is you're trying to break the thing, a large application into small applications or a large application small components so that it is easy to maintain. Then the next thing is the Java Enterprise Beans. Now this Java Enterprise Beans is nothing but EJBs or Bean is also like is very helpful in reusability, but Beans is going to have their own properties, that is set and get properties or properties through which or properties which we can manipulate or which we can change with much ease. So using this, using the enterprise beans or EJBs or Java beans, we can we can store the data very persistently in an object, and through that, and that object can be transferred, or that object can be passed on to the database. So a consistent model can be maintained. So beans are nothing but Java beans are nothing but objects which has properties through which the data can be manipulated or data can be stored actually. And these objects can be transferred or communicated to the database so that they can be so that the data can be stored. Then the next thing is enhanced web services. Now this part, enhanced web services, nothing but actually this is a combination of XML that is since one of the features platform independent. So what we need to, what this web services does is we can have an API and we can provide, which is known as a web services API. and provides a mechanism or approach to, approach to for others to actually access our data using business logics. So the response return to the components or to different platforms is nothing but in terms of XML, so that it can be easily understood by the um, other platforms or applications running on other platforms. Then the last thing is the support. Last feature of J2EE platform is that support for Web 2.0. This is actually uh, well, this feature was not there earlier in the earlier this one, but once the standards for Web 2.0 has been uh, introduced, it is actually Web 2.0 is mainly associated or related to web applications that actually allows in sharing of data and provides a user-centered approach or uses the user-centered approach, and it actually this feature actually helps the applications with the use of the technologies such as Java, server faces, JFS, what we call JSP, tag libraries, as well as with Ajax. Now, this 2.0 is an important feature since Ajax is one of the technology which is specified in 2.0 and which helps in great deal in trying to access the data without any network issues or without any data issues. So this was the basic features of J2EE. I can say that there's 6 to 7 features which are there for J2EE. Now the next thing, we move on is we have talked about the architectures styles. We said that database server is there, so no problem. Everybody knows that. Wherever database is running, if you make a server and have it on a connected to a network, then obviously it becomes a database server. Then GUIs, which is a presentation logic, are on the client side. That also not much has to be done, except that a browser or a personal device can be used to access the data. But what we have in the middle tier, from three tier till entire architectures, what we have as the middle tier is nothing but they can be two. They are servers only, which implement the business logic. So they are either web servers or application servers. A web server is actually a computer or a server running a web application. The main purpose of web server is to provide web pages to the clients or send the responses as web pages to the clients. A client can use a web browser to make an HTTP request, and this request is handled by the web browser. Now, web browsers may also contain the HTML code, or which may also contain the Tomcat server code, which is used to run. Which is used to run or handle the execution of Java in the servers. And then the most commonly used web server for Java, or servlets or for web programming using Java is the Apache Tomcat server. And this server is also, freely available. So there is no need to go into depth of this web servers. But what we need is a software which can handle the incoming request and outgoing request. So that is why Apache Tomcat is used as a web server. This Apache Tomcat web server, actually is used to handle JSPs as well as Java servlets. Then we have the application server. This application server is also a server, uh, but it actually implements the business logic. The application of server provides a GUI to the your client, and this client, or it's the first tab where you have the presentation part, and this application servers are little complex to configure, or little complex to run. But when we have large scale applications, then obviously we cannot use our simple web server. We have to use application server so that features of entire architecture, or the things which are there in entire architecture, can be implemented or can be used. Now, in application servers, we have so many, but for using Java, what we can use is the WebLogic application server, or WebSphere application server, JBoss application server, and Glassfix, Glassfish application server. Now, among all these three, Glassfish automatically comes with the web server itself. But the rest of the others are separately used web servers. Now, the WebLogic application server is actually developed or owned by Oracle, and it serves as the software application server for software applications, and runs on the middle layer or middle tier. Then we have is the, what do we call, JBoss server. Actually, WebSphere is from IBM. This WebSphere also provides the same functionality, but it is from the IBM, or developed by the IBM. Then JBoss application server is the open source. That is, anybody can contribute to that source code, and but the so coming to the as I said, that JBoss application server is the open source, so anybody can contribute. Then the last thing what we have is the Glassfish application server. This application server comes along with the Apache Tomcat server itself, and it has Glassfish application server has many more capability of server-side application and web services, and the Glassfish can also be downloaded directly from apache.org. So this was the basic things what we have as far as what we call the enterprise architecture styles are concerned. Now we will move on to the next thing, next part of the what do we say of the unit. We Now what we have after enterprise architecture styles is that is the database access through Java. It is known as database or Java database connectivity, or JDBC or JDBC. Okay, now let us talk about the database access through. Where, are we? Where am I? Okay. The database access through Java. Now, very first thing, this is a very important topic actually. Without database access or without JDBC, we will not be able to create a real world web application, because any web application you take it will be using database. Now, the very first thing we need to discuss is about the types of drivers. As we had the enterprise, different types of enterprise architectures, the same way here, JDBC, which stands for Java Database Connectivity, has got four types of drivers. First is the type 1 driver, or what we call it as JDBC ODBC bridge driver. First one is the type 1 driver. First one is the type 1 driver, what we call it as JDBC ODBC bridge driver. The second type of the driver is the part Java, part native drivers, or what we call as type 2 drivers. The third type of a driver is a intermediate driver, or it uses intermediate data access server. And the fourth type of drivers are pure Java drivers, or the drivers written in pure Java language. Now let us go into details of each drivers. Now in the type 1 driver, it is JDBC ODBC bridge driver. JDBC is Java database connectivity, and ODBC is open database connectivity. So OD is open database, ODB is database, C is for connectivity. So actually JDBC, actually Java has come later, and before Java we already had something known as ODBC, open database connectivity, to connect any programming language with the database. And this ODBC has been developed by Microsoft actually. So this type of a driver, actually it acts as a bridge. It interacts with the this Java driver, JDBC driver interacts with the open data ODBC driver, and then the communication happens. So type 1 driver actually acts as a bridge between Java and the open database connectivity. This actually has an advantage, that is, I mean, single driver implementation is used to interact with different data stores. So you create a bridge, and once creating a bridge, we will be able to access data stored in different databases. Maybe Oracle, or it may be MySQL database, any type of a database. And since ODBC are already there, which is much efficiently implemented, ODBC driver. So basically the communication between between the ODBC and the actual database is much faster, efficient. And there are several disadvantages also. That is, the execution speed is less in terms of large number of transactions, because every transaction has to go through that same type of driver, which is a bridge driver. So it has to first go through a JDBC part. What you see over here, whenever a call is made to access the database, and then from here it has to pass to the ODBC driver, and from ODBC any database can be accessed or used. So the disadvantage is that the execution speed is very large. I mean, the programs are not faster in accessing large amount of data. And this type of driver, the JDBC over here, this depends upon the ODBC actually, because it's a bridge. So this is what is actually a bridge between, I mean, JDBC and ODBC. Now, actually, we are looking at a Java programs which access the database, but the main disadvantage again over here is we have to depend upon the ODBC driver. And so this type of driver is actually type 1 driver is not suitable for large scale applications or for large scale production environments or a large scale website actually. Then we have what we say is type 2 drivers. In this type 2 drivers, we are not using ODBC. This layer has actually some part which is implemented for Java. That is from the Java, calls are made to different. I mean, a call is made to access the database, and then since the databases are traditional databases, or Crackle or MySQL or traditional databases. So therefore, what happens here is that the native access or the original access for to get the data, actually to retrieve the data, is through native code. Native code in the sense the old written code. That is, for example, the database may have an API to give an access to written in C and C++ to give an access to the data. So the native drivers means some drivers are using the previous language, native language for that databases. That is, for example, C and C++. But since Java program cannot directly access those native drivers, so we have something as part Java and part native driver. The advantage of this driver, it's a little faster than the type 1 drivers, but there is also a disadvantage. That is, we need to know the native library. That is, which programming language or uh, what is the methods or which language those methods are written so that we can interact with the database. As well as there is an increase in cost. With increase in cost when this type of drivers are used. But always remember that these are much better in execution speed in terms of type 1 drivers. But the other disadvantage is that we have to know the native library to implement the programs or to access the database from a Java program. Then we have, so this is the type 2 driver between your Java application and the database. So this type 2 driver is part Java, part native. Then with respect to the type 3 drivers are actually, there is some middle layer between or middleware server between or intermediate server between the JDBC program, that is between the type 3 driver and the actual databases. So type 3 driver actually uses or translates the call from JDBC application into database server, which is independent, and it is there as a middleware. And that server actually responds, I mean, sends a request or communicates with the actual databases, that is SQL Server or Oracle or MySQL server. And the data, once accessed, is given back to the JDBC application. The advantage of this over the previous two types is that any driver, any database can be used here. Now, sometimes in ODBC, JDBC, OD type 1 driver, what happens is there may not be any ODBC open database connectivity for some databases. So we will not be able to access those databases. But here in the type C driver, it serves for all Java drivers actually. It serves for all databases. and does not require any native library or the knowledge of any native library, as we discussed in type 2 drivers. And we do not need to know the details about the databases. Everything is handled by the intermediate or the middleware server there. The major disadvantage here is that type 2 drivers are a bit faster than type 1 drivers. But type 3 drivers, the main disadvantage is that this driver is very slow because it has to, there is an intermediate processing or the middleware server or the intermediate server, and the calls has to go through several, network calls has to be made when compared to the actually type 2 drivers. So type 3 drivers is a little costlier when compared to the other type of drivers, as well as there is much of the network calls needed in that. But the major advantage is that it supports for all databases, and we do not require any knowledge of any native library, or we need not install any native library on the client machine to access the database. Then Then we have is the type 4 drivers, which are known as pure Java drivers. Now here, if you see, there is no much, this is same as type 2 driver. The except thing in type 2 and type 4 driver, compared to type 4 driver compared to type 2 driver is that in type 2 we had part Java and part native drivers or libraries. But here, in this type of driver, everything is in pure Java. Uh, Even the database access or the protocols which are used to communicate with the database, everything is in Java. There is no separate native library or any other thing to access. And this is much better. Type 4 drivers are much better and has more advantages. The very first thing is that since it is in Java itself and do not, and directly Java can interact with Java applications to access the database. So this driver is much faster than the other type of drivers. And this driver does not support, any native library, or no native library is needed to be installed. And this actually type of driver gives you exclusive access to the database, and there is no actually middleware server or anything which is required in the middle to access the data. But the major disadvantage of this type of a driver is that each vendor provides its own what do we call specific protocols to access the data. For example, Oracle is there. So Oracle will provide its own protocols to access the data. MySQL is there. Is going to provide its own protocols or rules to access MySQL data. In the same way, the other what do you call, like for example, SQL Server is there. So Microsoft will provide its own access in Java. Obviously, every vendor will provide Java protocols or protocols written in Java, because this is a pure Java driver to access the database. So every vendor provides its own set of rules, set of protocols to access the database. But remember, type 4 drivers are very fast, and their execution is much faster compared to all the rest of the previous three drivers. So this was basically about different types of drivers that we have to use in a Java database connectivity or a Java program which we write to connect to a database. Now, Time is up. So actually, what we will do is just I mean, just I'll stop presenting. Where is it? Okay, let me come back to this one. Now I have to continue further. So why am I? I don't know. Okay. So can we have a class in the afternoon, 2 o'clock? Just reply me. Anybody can send a chat message or so. Can we have a class at 2 o'clock today to continue with the Java database server or access? Okay, then I'll post a message on the group. Others can also join. We will again continue with the same topic, that is Java database connectivity, and we will join back at 2 p.m. today. Thank you very much. And if any doubts, any questions are there, we will take up at that time. Okay. Thank you. We will join back at 2 p.m.